Hey Chemsters, this is Mrs. Vandelay bringing you Chemster video. This is Chapter 7, Acid Nomenclature. We've already done ionic. Now it's the time to learn how to name acids correctly. And you still have to know your polyatomic ions. Hey folks, they don't go away. What makes acid nomenclature a little bit easier is that your cation is always hydrogen. So you never have to worry about the plus part of it. You only have to worry about the anion, the negative part of it, okay? So you always have to look to the anion to name the acids. So there are only 3 rules. It's really not too bad. If your anion ends in "ide", then it's hydroic acid. All right, and how can you remember that? Well, there's something called my ride has hydraulics. Hey, let's say that together. Everyone, my ride has hydraulics. Do you see how that works? So if you haven't already, please jot that one down. Then if your anion ends in "ate", then it's ic acid. So here's a little saying here. I ate something icky. Hey everyone, let's say this together. Ready? I ate something icky. So that tells you that it's an ic acid. And then the last one is if your anion ends in "ite", it's an something us acid. So guess what? I have a saying for that too. Ready? Here we go. My Sprite is delicious. Everyone, let's say it. My Sprite is delicious. Hey, I didn't hear you. Say it again. My Sprite is delicious. So if you can remember those 3 sayings, you got this, okay? So let's see how this works. Let me scroll down. So for example, if we have HCl, so here, cover up the H. All right, I covered up the H. So what's left? Cl. You should recognize that as an anion. It's your chloride. It's a single anion, so that means it comes straight off the periodic table. It is not polyatomic, so it's just chloride. So what was the saying for if it ends in "ide"? My ride has hydraulics. Remember that? My ride has hydraulics. So what is the name of this? Hydrochloric acid. Hydroic acid. My ride has hydraulics. Okay, let's try the next one. Well, let's cover up the H's here. All right, hey, what's left? It's SO4. Do you recognize SO4 as anything? What is SO4? It is sulfate. Oh, I ate something icky. Remember that? So what will be the ending? Take off the 8 and put ic acid, so it becomes sulfuric acid. So go ahead and put the back in. It sounds better than sulfic, doesn't it? All right, so it becomes sulfuric acid. Don't forget to put the word acid at the end. All right, but the next one, let's cover up the H. Ready? Here we go. Hey, what's left? I believe it is NO2. What's NO2? It's what? Nitrite. So now what? My Sprite is what? My Sprite is delicious. So take off the "ite" and put us in there, and you get nitrous acid. Okay, do you see how this works? So let's try the next one. Cover up the H's. What do you have left? Do you know what that is? Well, it's CrO4 negative, all right. What is that? You have to know these, don't you? It is chromate. Hopefully you knew that. I was waiting for you to say it. All right, so what is this one? Think about it. I ate something what? Icky. That's right. So it becomes chromic acid. There's my ic. My ate is ic. I ate something icky. All right, cover up the H. What do we have here? Oh, do you remember this one? This is a special one. What is that one called? Do you remember? It's a special one because it's one of the 2 that ends in "ide." So hydroxide and cyanide. All right. So HCN would be what? Ide. My ride has hydraulics. So this becomes hydrocyanic acid. Okay. Why don't you try the next 3 on your own? So why don't you just pause this and see how you do. Come right back. hopefully that was enough time for you to figure it out. Hopefully pause it, and when you're done, you came back. So here is covering up that one. So you recognize that as ClO3 negative. What is ClO3 negative? That is chlorate. Very good. So I ate something icky, so that becomes chloric acid. So what about the next one? Cover up the H's. Well, what do you recognize that as? SO3 2 negative, which is what? Sulfite. My Sprite is delicious, so it becomes sulfurous acid. And finally, cover up the H, you're just left with F. F by itself. It is just an element, not a polyatomic. So it becomes what? Fluoride, doesn't it? So F minus is fluoride. So my ride has hydraulics. So it becomes hydrofluoric acid. Well, hopefully that is getting a little bit easier. So let's do the opposite. What if I give you the name, then you tell me the formula? So let's scroll down a little bit. So for example, we have hydroiodic acid. So the ending of the acid is hydroic. So my ride has hydraulics. It begins with just iodide. Now there are such things as iodate, periodate, iodite, and hypoiodite. Those all exist, all right, but it's iodide because it's hydroic acid. So this is really, really important. So in the first one, or the examples above, you had to know like SO4 would be sulfate. Well, here you have to know the charge. You just have to know the charge. So look on the periodic table, it's group 17, iodine is. So what is the charge of all group 17? It's -1. Why is that so important? It is the charge that determines the number of hydrogens. Why is that? Well, hydrogen is a +1, so when you crisscross, you always get whatever the charge of the ion is how many H's there are. So let's try a couple of these. So we have carbonic acid. What's the ending of carbonic acid? I believe it is ic. So what is the ending of ic? I ate something icky. So what's the ending of my ion? It's carbonate, isn't it? Sorry about that. It's carbonate. Oops, wrong one. It is carbonate. I see acetate's coming up. So now what? Well, what is carbonate? You must know what carbonate is. So if you recall, carbonate is CO3 2 negative. And why is that so important? Well, how many hydrogens will go on carbonic acid? Well, what's the charge of carbonate? It's 2 negative, so 2 hydrogens jump on. Okay, see how that works? All right, so the next one is chlorous acid. So chlorous acid ends in us. So my Sprite is delicious. So it becomes, oops, chlorite. I'm having a little issue here. There it is, chlorite. So what is chlorite? You have to know it. It is ClO2 -1, all right? So why is that important to know your charges? Well, how many H's are going to bond with the chlorite? Just one of them. All right, so it becomes HClO2. All right, here's my next one. It's acetic acid, so it ends in ic. I ate something icky, right? I keep saying that, but actually I have some good food over today. Anyway, so what is acetate? Oh, it's one you have to memorize, and it's C2H3O2 negative. What's the charge? -1. So how many hydrogens can hop on this? 1. That's right. So here we go. There it is. So it's C2H3O2. Now, what's the next one? Hydrobromic acid, hydroic. My ride has hydraulics. So what is my ending? It's hydroic. Actually, it's my beginning and my ending. So what is going to be the name of my anion? Well, my ride has hydraulics. Whoa. Sorry, seem to be having some technical difficulties, but we're almost done, so that's not too bad. So anyway, what is bromide? Bromide is Br negative. Okay, how did I know it's a -1? Well, what group is bromine in? It's in group 17, so the charge is -1. All right, so what is the formula for my hydrobromic acid? Well, I put 1H in front. So why don't you pause this, all right, and try these on your own, and when you are done, come back. All right, well, welcome back. Hopefully you got ick here. So I ate something icky. Hopefully you know that nitrate is this, and I only put one H in front of that. Oxalic acid. So I ate something icky. Did you have to go back and look up what oxalate is? Hopefully you got C2O4, 2 negative. So how many H's will go in front? That gives you 2. So the last one is phosphoric acid. So I ate something icky. So I got phosphate. Well, what is phosphate? It's PO4, 3 negative. It's your special one. It's the only one that's a -3. So how many H's go out in front? Oh, 3, and there you go. So tomorrow in class, we'll be practicing these. So I hope this helps you out, all right? So here's my ending for you, something to think about. Hey, folks, don't wait to be great. We'll see you tomorrow. Bye-bye.